Welcome to TheTechMechanic. Imagine 1 million users open Amazon at the same time. Every user wants product details, prices, and recommendations. Should every request go directly to the database? If that happens, the database becomes overloaded and the application slows down. This is why architects use caching. Today we'll learn the difference between a database, a cache, and Redis, and how architects decide when to use them. A database is designed to store information permanently. Customer accounts, orders, payments, and product information are usually stored in databases. Databases focus on reliability, consistency, and durability. Even if a server restarts, the data remains available. This makes databases the source of truth for business applications. However, retrieving data from a database can take time, especially when millions of users are making requests simultaneously. Imagine a product page receiving thousands of requests every second. If every request goes directly to the database must repeatedly perform the same work. CPU usage increases, response times become slower, and costs rise. The problem is even worse when the requested data rarely changes. Architects look at this situation and ask a simple question: why fetch the same information repeatedly when we can keep it ready in memory? A cache is a temporary storage layer that keeps frequently accessed information closer to the application. Instead of asking the database every time, the application first checks the cache. If the data exists in the cache, it can be returned immediately. Because cache data is stored in memory, it is significantly faster than reading from a database. This improves user experience and reduces database load. Redis stands for Remote Dictionary Server. It is one of the most popular caching technologies used in modern applications. Unlike traditional databases that store data on disk, Redis stores data primarily in memory. Accessing memory is much faster than accessing disk storage. This is why Redis can process thousands or even millions of operations per second with very low latency. A common architecture pattern is called cache-side. When a user requests data, the application first checks Redis. If the data exists, Redis immediately returns it. This is called a cache hit. If the data does not exist, the application reads from the database and stores the result in Redis for future requests. This is called a cache miss. Over time, most requests are served directly from Redis. Let's revisit our shopping application architecture. Product details are requested frequently, but they don't change every second. Shopping carts are accessed constantly during a customer session. These are ideal use cases for Redis. Instead of reading from databases repeatedly, the application retrieves the information from Redis. This improves performance and helps support large numbers of users without overloading backend systems. Let's compare them. Databases store data permanently and act as the source of truth. Redis focuses on speed and temporary storage. Databases prioritize reliability, while Redis prioritizes performance. One does not replace the other. Architects use databases to store business data and Redis to accelerate access to frequently requested information. Architects ask a few simple questions. Is the data requested frequently? Does the data change relatively infrequently? Is performance important? If the answer is yes, Redis becomes a strong candidate. Product catalogs, shopping carts, session information, API responses, and recommendation data are all common Redis use cases. The goal is to reduce database traffic and improve application responsiveness. Let's summarize. Databases are designed to store information reliably and permanently. Redis is designed to make applications faster by keeping frequently used data in memory. Great architects understand that databases and Redis solve different problems and work best together. In our next video, we'll explore another important architecture concept: REST API versus message queue versus event-driven architecture. Don't forget to like, subscribe, and follow the TechMechanic for more real-world